All right, welcome to some math. I know we love math. This unit we have with waves has a little bit of math to it. Should be actually fairly basic as long as we remember that we have a reference sheet to be able to get to. So with this image, we've got just a typical wave. There's a lot of things labeled on here. The math that's involved with waves simply tries to kind of go through the relationships between a few things such as wavelength and down here, which is the frequency. Those two things have a pretty much an inverse relationship because as the wavelength shrinks, then the frequency is going to go up because they're closer together. There's also a thing about speed. Speed kind of is involved in this as well. And then this concept of period, which is the amount of time it takes for each wave to pass. So there's a relationship between all of these. They are seen in your formula sheet, and we'll get to that in just a minute. So what we're going to do is look at how do we calculate frequency, how do we calculate a period, how do we calculate a wavelength, how do we calculate speed. Of course, we have to be given several things to be able to do this. And again, want to encourage you to take notes, specifically copy some examples, because the follow-up to this is to do some practice problems that look a lot like these. And so if you don't have examples in front of you, it's going to make it a little bit harder. And again, you can upload them for extra credit. All right. So again, this is our formula sheet. Again, we've got some terms. There's this F for frequency. There's this upside down letter Y that looks a little bit like a chicken foot. I believe it's the Greek letter lambda, and it stands for wavelength. Capital T stands for period. I guess that has to do with time to some degree, but it's not a P. So the capital T is period. V is our speed or velocity, like we've had before. And temperature is in Celsius, because we'll get to this down here at some point, but not today, that the speed of sound depends on the air temperature. Fascinating, I know. So we'll get to that later. But today we're looking at these top four. So that frequency is oscillations, and all that an oscillation is basically something moving back and forth, a vibration, something going up and down, divided by time. Frequency can be 1 over the period. The period is 1 over the frequency. Notice that those can kind of be exchanged for one another. And fundamentally, velocity is frequency times wavelength. And this formula, to use this formula, it's a lot like using Ohm's law, where voltage is current times resistance. You can make a triangle out of this if you need to be able to solve for things however you are given them. So again, anytime we want to, oh, that's really bad, try to make the triangle thing out of this, remember the two things that are multiplied end up going on the bottom. So this would be frequency. Let me change the orientation of this. Maybe that helps my writing a little bit. Times wavelength, and then the velocity is going to be on the top of that. So again, to solve for velocity, you multiply these together. You could solve for frequency by dividing these two, and you could solve for wavelength by dividing those two, right? So again, any formula that you have that takes this form, we can always put it into the triangle to be able to solve whatever it is we need to solve. I'm going to go through a few examples, not too many here. So first question is, the frequency of a wave is 560. What's this period? Again, just like anytime we're solving math problems, it's really helpful to go through and make sure that you kind of label everything that we've got. So 560 is the frequency. Again, frequency is the F. So our F is 560. And it's just asking for the period, which is T, which we don't know. And if you look with this, we've got a formula that puts both of those together, nice and easy. So to set this one up, I would do T is 1 over the frequency, which is 1 over 560. We need to throw that into a calculator, so let me grab that. And again, you should be able to do this on your own, but 1 divided by 560 is going to give me a really small number. So it's going to be 0.00, basically like 18. And again, this is its period. This is going to be in seconds. And you may say, did I get something wrong with that? That's a really small number. But if the frequency is 560, again, that's usually 560 times per second. So if something's happening 560 vibrations per second, then the amount of time in between each vibration is going to be really, really tiny. And that's where that number ends up coming from. Okay, so that's how we would go about doing a calculation for that one. Told you these are going to be easy, not that much to them. So we got a couple of things to look on this one. Girl floats in the ocean, watches 12 waves crest pass her in 46 seconds. So we want to calculate the frequency and the period. So let's see, we've got 12 waves in 46 seconds. So what can we do with that one? Well, that's 12 waves. There's a number of oscillations. 46 seconds is our time. So from that, we can get, that's how we're going to get the frequency, is oscillations divided by time. So it's just going to be 12 over 46. Put that in our calculator. And because this is a frequency, frequency has its own unit of measurement called hertz. So this is going to be about 0.26 if we round Hz for hertz. So that gives us our frequency. And how can we calculate the period? We would do that just like we did in the previous problem by putting 1 over 0.26. And if we put 1 divided by 0.26, we get 3.85. And that's your, so here's your frequency. That's part A. And there's your period. That's part B. Again, I'm going to move through these pretty quickly to keep the video short, but you're welcome to pause, rewind, do what you need to so that you get these written down as best you can. We'll move on to the next one. Again, I think I only have 5 of these. So we're asking for how many cycles will the energy source make in 22 seconds? So the period of the wave is 0.044 seconds. How many cycles will the energy source make in 22 seconds? So let's see, what all do we have here? We got T, which is our period. I'll write a little slower for the ink to keep up here. How many cycles will it make in 22 seconds? So we've got a time right here, right? See how we can figure things out. So if I know my period, what all the things can we get right here? So we're trying to say how many cycles. This is basically what the oscillations are. So it's going to be a 2-step problem because I know my time, but I don't know my frequency. However, if I know the period, I should be able to figure out my frequency. So I need to get my frequency to solve this. So I'm going to start with this formula because I can get frequency is 1 over 0.044. Right, so 1 divided by 0.044, 22.73. Right, so that's 22.73 hertz. Again, that's my frequency. So now I know my frequency and I know my time, but I don't know my oscillations. So again, let's think about it. You could make this into your triangle formula if you need to. Oscillations is on top of this fraction, so the oscillations is on top. So to get the oscillations, I need to multiply the frequency times the time because they would both be on the bottom of our triangle if we turn this into a triangle. So I know my frequency is 22.73. I know my time was 0.044, so I'm going to multiply those together. Just a second. All right, I had to take a little pause there for a minute because I was looking at how I was working this out and I was like, I don't think I did something right. And so I needed to double check because I don't want to double check while I'm sitting here staring at the screen. And I realized what my mistake was. Again, everything I told you was correct. It's still frequency times time, but I made a little bit of a mistake, which is probably going to be easy for you to make. Again, because if I'm making it when I'm working this out, it's probably easy for you to make. I said to multiply frequency times time, and I said frequency was 22.73. The time was 0.044. But here's where you have to be careful is that big T is not time. So be careful. That big T is period, right? Time is up here. So don't make the same mistake I did. Again, I don't mind showing you when I make errors because it may help you to prevent yourself from making errors. So what I really need to do is multiply frequency times time. Here's my frequency is 22.73 and my time is 22. So let's multiply those two together. I kind of realized I caught something wrong because when I initially multiplied those together and got 1, I was like, wait, that doesn't seem right. That seems like a kind of an incorrect number that we have there. If I multiply these together, I get approximately 500. If I round it, I get pretty much right at 500. And again, it's how many cycles is it going to make? So it's going to make 500 cycles. So good learning point there. Capital T, not time, right? It's the period, which is a time, but it's not the same time as this time. So this is the time that we would use, and like how much total time do we have that we're measuring This t is the amount of time between each cycle that comes through. So they're both time, but there's slightly different times. So glad I could mess up in front of you on a video. It's there forever now. Okay. All right, so next one. What's the speed of 256 hertz sound with a wavelength of 1.35 meters? So again, we're looking for what's the speed. That's going to be our velocity. So we're trying to solve for v, right? 256 hertz, that's a frequency. And wavelength of 1.35, that's our lambda chicken leg upside down y. So I've got a need to solve for v. I know f and I know lambda. That's going to use this formula down here. And looks like all I need to do is to multiply f times lambda together, because to get v, that's all that I do. So I just do 256 times 1.35. That's going to give me my velocity. So 256 times 1.35 is 345.6, and we're done. And again, it says speed, and speed's always going to be meters per second with these. Hertz, again, uses, when we're using all these terms, we're always using meters and seconds in our measurements to do these. All right. I think I got one more. Let's see. Yep, so this is the last one. You're dipping your finger into a pan of water 14 times in 11 seconds, producing wave crest separated by 0.16 meters. Lots of numbers. What's the frequency? What's the period? What is the velocity? So what all do we have here? So I've got 14 times in 11 seconds. 14 times in 11 seconds, that's basically, this is our oscillations and this is our time. So from oscillations and time, we should be able to get the frequency. So 14 divided by 11 is going to give us our frequency. So that tells us it's going to be 1.27 hertz, which is, again, that's 1.27 times per second. That's what that's going to give us. So there's our frequency. Our period is 1 over the frequency. So P is 1 over 1.27. Again, this is going to tell me how much time is there between each wave. And there's about 0.79 seconds, which makes sense because I'm tapping more times than there are seconds. So my time should be a little less than a second. So there's that. And there's that. And then what's our velocity? I need to multiply the frequency, which we've already got at 1.27. So we got our frequency here, right? And we're going to multiply that times the wavelength, which is given to us in the problem. So again, 1.27 times 0.16. That's going to give us our velocity. 27 times 0.16 is 0.203. I'll just leave it at 0.20. And then again, velocity, it should be in meters per second. And we're done. All right. So effectively, that's what we need to do with our math. Pretty straightforward. Just make sure you don't do like I did and, confuse time for oscillations with capital T time. Again, the difference between these two is that this time is going to be the total amount of time that we're recording for waves to come by. The capital T time is the amount of time between one wave to the next wave. So it's a little segment of time. They both mean time. The capital T time is not total time. Don't make that mistake that I made. And the rest of this should be pretty easy and pretty straightforward if you're using your reference sheet that you've got over here. All right, probably have some practice to do to follow up with this. And if you need to upload your notes to get extra credit, do so.